Okay, so now let's have a look at the next of our new derivatives that we want to look at. It's our log function. Okay, so the derivative of log x is just simply given by 1 on x. All right, and in the same way, surprisingly enough, the derivative of log e k or log base e of kx is also 1 on x. All right, but I think the nice thing to remember here is this rule here. All right, so let's treat it this way. It's this one here, okay? That's the one that's on your formula sheet, but I think it's this one here that is most useful, all right? So what we're saying, the log of the function, all right, the derivative of that is given by the derivative of the function over the function itself. So if we just look at practical applications of that, so dy dx is equal to the derivative of 2x, which is 2, over 2x, which is the function, which is then just simplified to 1 on x. All right, same thing, dy dx is equal to, we've got -5 out the front, which is a constant. The derivative of a half x is a half over x on 2. All right, so -5 times a half is -5 on 2. So we're going to have our -5 on 2. So that's the same as -5 over 2 times x on 2. They cancel. We get -5 on x. All right. So f dash of x is equal to 2 times 5x plus 2. The derivative of 5x plus 2 is just 5 over the function, which is 5x plus 2. So that could be equal to 10 over 5x plus 2. All right. What about here? Same sort of thing. Now we've got g dash of x is equal to, now it's the derivative of that function over the function itself. So I know the answer is going to be over the function itself. We just now have to work out the derivative of 2 minus 3x to the power of a half. From my chain rule, I know that that's equal to a half times 2 minus 3x, take 1 from the power, times the derivative of inside, which is -3. So that's equal to -3, if you like, on 2. And let's bring that square root down here to 2 minus 3x. Yeah. So that means I'm going to get -3 on 2 over square root of 2 minus 3x. So let's bring everything into the denominator. -3 over 2 root 2 minus 3x times 2 minus 3x. So that's the same term squared. -3 over 2 times 2 minus 3x. So that's just as easy to leave it in that form there. All right, so there's no doubt the algebra part of it was a little bit messy in through here, okay? But it's just taking your time. We had to incorporate a chain rule over here so that we could differentiate the 2 minus 3x to the half, all right? Then we have this term divided by the other term, all right? Don't forget with some of them, it might be simpler to use our log laws first. So 2x minus 1 to the power of 3. In fact, geez, let's do this one first and let's do the other one in a much simpler way. 2x minus 1 to the power of 3. Well, that 3 can come out the front, can't it? So that's the same as 2 times 3, natural log of 2x minus 1. So the derivative of that is equal to 3 is a 6 times the derivative of 2x minus 1 is 2 over 2x minus 1, which is 12 over 2x minus 1. which gives me a hint in here. Okay, let's think about that one again. So let's maybe bring that one up here. That natural log of root 2 minus 3x can be written as natural log of 2 minus 3x to the half, can't it? Half comes out the front. Half natural log of 2 minus 3x, which means we get a half times the derivative of that, which is negative 3, over the function itself, which is 2 minus 3x, which is equal to our negative 3 on 2 times 2 minus 3x. That should be, Mr. Gale. Yeah, same answer, but how much easier was that? All right, just because we picked up on the little log law that we could use first. So, example F, we have y equals. So let's write first things first. We'll just rub that out. Let's rewrite it as y equals natural log of. Oh, we've got the 2 on top. What are we going to do with that? No, I was going to try and write it as a 2 minus 3x to the minus 1. I don't think we can get away with that in this case. So we might just have to leave it as that. Let's go back a fraction. So we're just going to need to write it as dy dx equals, what is the derivative of 2 times 2 minus 3x to the minus 1. The derivative of that is equal to negative 1 comes out the front, 2 minus 3x, take 1 from the power, times by the derivative inside, which is negative 3. So that gives me negative 2 by negative 3, which is 6, over 2 minus 3x squared. Okay, so that means my derivative is equal to 6 over 2 minus 3x squared divided by 2 over 2 minus 3x. All right, so we can simplify that by flipping the bottom function and multiplying. So that means dy dx is equal to 6 over 2 minus 3x squared times 2 minus 3x over 2. Squared cancels with that. 2 into 1 into 6 is 3 times to leave me with 3 over 2 minus 3x. Okay, so again, a little bit of manipulation, but the log function, same thing, isn't it? It's the derivative of the function inside goes on top, and that goes on top of the function as a whole. All right.